Hello, and welcome to the xOpera TOSCA use case overview. We appreciate you all being with us today. Just a few announcements before we get started. As you can see, this presentation will be recorded. I will follow up with all of you in the end and send you a link to the recording just in case you missed anything. We will be taking questions at the end of the presentation, but do feel free to type them in the chat or the Q&A, whichever you're more comfortable with during the presentation, just to make certain that we snag all those. And sometimes you'll find that it will get answered in the process, but at any rate, and we will have some closing announcements in the end as well. So today we have two presenters. We have Mattia Kanker, a researcher and project manager at XLAB, and Anja Luzar is a software developer and researcher at XLAB. And with that, Mattia, please take it away. Thank you.
Okay, thank you. Thank you, Dee. Thank you for inviting us and giving this kind introduction. We are really honored to be here on behalf of XLAB company and appreciate that you gave us the opportunity to present the xOpera project today, which actually started as a small and simple TOSCA orchestrator, and hopefully today we will convince you that it's more than just that. So in today's agenda, we will, let's go through the agenda. So first thing first, I would like to quickly present how we ended up here, who we are and what we do, and why we created xOpera. And then we will provide you some insights of the xOpera project. And we'll finish this webinar with a demo and questions. So we are from XLAB. XLAB is a global IT solutions company founded in 2001 in Technology Park in Ljubljana. This is from Slovenia. This is in European Union. What is special about XLAB is that our solutions are based on the breakthroughs of our own research team that is ranked among the top of 50 European small and medium-sized enterprises in the context of participation in European research projects. In the past 2 decades, our team grew, and currently there's more than 120 of us, and we are all on the same mission to get IT done, which is our slogan. So our customers, we know us by our products from diverse range of sectors, but I limit only to the most relevant ones for today. One is ISL Online, which is a pioneer in the remote desktop industry. It allows users to instantly access any computer or mobile device to provide technical support or manage systems remotely. And the second one is steampunk services that help companies accelerate their businesses by adopting IT automation. So beside the great research team that I mentioned also before, thanks to Steampunk, we established a long-term trusted partnership with Red Hat and contributed to the much open source products. So this brings us to our activities in open source. So we believe in open source collaboration and giving back to the community. That's why we're also happy to collaborate with OASIS Open Standards and the TOSCA committee. So we have been much involved in distributed and cloud computing in the past decades, providing support, ideas, and solutions to how to improve things. So we contributed also to OpenStack, Ansible. Since recently, our employees are also the chair of the Ansible Community Steering Committee, for example. And this is how we ended also with creating our own open source projects like xOpera or Redfish tools and others. So now, why xOpera? The idea of creating the orchestrator came after providing our IT automation expertise to our customers and research projects. This was our opportunity how to push things forward beyond the state of the art on this field. And the idea was to create a simple and general purpose orchestrator, extend the power of the existing automation tools available, share good practices, deployment templates, Caesars, among others, and provide a solution to multiple EU research projects, like those presented here, which are Sodalite, Radon, Piacere, and Fishy. Going forward, our vision with xOpera project is to provide an ecosystem that provides all necessary tools for orchestration. xOpera is actually a project, a sandbox for that ecosystem, and Opera is our orchestrator. Orchestrator or orchestrator core, CLI, and API are lightweight and open source solutions. Orchestrator is also state aware. It is based on Ansible executor, so it combines imperative and declarative approach, and it currently uses TOSCA version 1.3 specification. So where you can get xOpera, you have the main GitHub page, and there is also the QR code that you can use right now. You have also the main documentation page. Also, there is a link and QR code for one of the starting videos if you like to see the video tutorials or something like that. But for those who would like to deploy something right away, you can go to the console, you put in the pip install Opera, and after installation, you are ready to deploy some TOSCA templates with our tool. So now, after this, I'll present a little bit of the xOpera toolset and architecture, how things are connected together. So first, this is kind of our architecture and how the toolset are connected together. And the rightmost here right now, I present the core. So core is the part where the orchestrator parses your TOSCA template, prepares the instance model, and executes the deployment and configuration. And then going forward, I present the CLI. So the CLI is a command line interface to that xOpera core that you can download through the PyP, of course, and then you can also get it on the GitHub. Like we already shown the links on where you can get xOpera slide, for example. The CLI is for the developers actually the most common way to use xOpera. Then we have the xOpera API. The xOpera API provides the ability to integrate Opera in your application or your project. You can install it also through the PyP and covers similar operational tasks as CLI and also allows independent development from the CLI. Then next one, very important, is the xOpera SaaS and its plugins. So this is xOpera software as a service. With the plugins we have are also, as you can see here, the Visual Studio and the Eclipse J plugins, and also it has its own web graphical user interface. So xOpera as a service is a kind of an orchestrator as a service. This is where you can log in and this service environment for each of your deployment projects. It has API and ID integrations, Visual Studio and Eclipse J, like I mentioned before. It uses Keycloak for OpenID support. It provides you user and credential management and multi-tenancy. Things are organized in workspaces, which are the set of projects. And in projects, project is an individual deployment blueprint, for example. And all those things will be also shown in action in a demo. Everything here is that it means that you can organize multiple deployments in your enterprise along multiple teams, for example. Also here we have, I should not forget to mention callbacks. initiate triggers described in the TOSCA templates. So here are some screenshots of the xOpera software as a service dashboard, workspaces, secret management, and similar. All those you will be able to see in the demo. So next one is the template library publishing system, which also have the plugins for Visual Studio and Eclipse Chair. And also it has plugins for CLI. So the idea of template library publishing service is to store and share TOSCA models and blueprints. The template library is available online. You can also get the documentation and the CLI client if you want. And the CLI client is also available on Pipey. The idea is also that in the template library publishing system, you can have your own private blueprints, and you can go here. Here is also some screenshot of the xOpera TPS, where you can see the service catalog and the services that are available, that are here, are also available through the xOpera SaaS. The last that I will mention right now is the xOpera HPC, which is a special clone of xOpera service tailored for our partners that are focused on high performance computing. So for now, I guess that I need to stop talking and give the floor to Anje, who will show us the xOpera in action. So this is now the demo. I'll stop the sharing.
Okay, so you can probably all hear me, and I'm just gonna take over. So my name is Sanjay, and today I'm gonna demonstrate you how you can use the xOpera tools and how xOpera project can facilitate your deployment use cases along with your automation and orchestration projects. So I will share my screen. Okay, so you can probably all see my screen. So we are currently located in our xOpera repository. So I just have to navigate to our main core repository, which is called xOpera Opera, and this is our GitHub page. So here you will find the core xOpera orchestrator, which is written in Python, and you will also find some interesting links and facts about xOpera, the orchestration standard it supports, and the implementation tools like Ansible. This README will also get you started, and it will show you some quick start example. But most importantly, you will be able to see this link, which if you click on it, will take you to our xOpera documentation, which is available publicly on our GitHub pages. And here you will get to know how it all started, what is the architecture. The documentation is also populated with interesting videos that will show how xOpera tools can be used. And of course, every xOpera tool is described on a separate tab, like you have xOpera CLI, xOpera API, xOpera SaaS. This will be our main target today. You have the template library, or xOpera TPS, which is also documented on a separate documentation page. And most importantly, you have the examples. So the examples are basically described separately and more in detail on this page. And all the examples that I will show you today are available publicly in xOpera examples GitHub repository. So if you navigate here, you can see that the examples are separated into folders. Perhaps you have cloud examples, CSARs, examples that target Kubernetes and Docker, miscellaneous examples, and examples that use various TOSCA entities. So let's get started and stop talking. So you know that xOpera orchestrator is available as Opera Python package. So if I go here, this will take me to the PyPy. So if you go to PyPy and if you type Opera, you will be able to find xOpera orchestrator, and you can install it with pip install Opera. So I will navigate to PyCharm, where I have my console, and I also cloned xOpera examples GitHub repository. So the easiest way to install Opera is to prepare a new Python virtual environment, which I already have done. And I will activate it with this command. And when you have a new virtual environment, you can basically just type in pip install Opera, and this will install the orchestrator. So I already have it. And when you have installed it, you can basically just type Opera -help, and this will show you all the options and all the commands. So it's a lot of commands, but we will dive right in. So usually when you start using new tools, you start with a hello world example, and we'll do exactly that. So I will navigate to miscellaneous folder, and I will click on hello world example. Each example is of course equipped with its own README, where you will find how to run it and what the output of the deployment should be. So you can see that this example is a very simple example. It consists of one TOSCA service template file, which basically has only one node type called hello type. And this hello type basically implements two operations, create and delete, which will be later invoked with Opera Orchestrator. And because we use Ansible to implement the TOSCA standard, those interface operations point to the Ansible playbooks. And these playbooks in the Hello World example are pretty straightforward. There is the create playbook that basically just creates an example file with the content from this marker variable, which is defined here as an input, but it already has an example value. And the second playbook is delete, which basically just removes the temporary folder with the file. So what we need to do to deploy this example, basically we navigate into miss and hello world. And the most simple command is Opera validate, which will tell if your TOSCA service template is correct. So this Opera validate command tried to parse the TOSCA template, and it also run some kind of check mode on the executors on these Ansible playbooks. So after you validated the example, you can run Opera deploy, which will deploy the service template. This means that we invoke this create playbook, and if everything went okay, the location and this file should be present on our file system. Okay, it's here and it has the default marker content. So, and again, the other command is Opera undeploy, which will delete the location and it will invoke the delete playbook. So the location is no longer present, as you can see. Okay, so this is just the basic example, but you can see the logic behind that. So now we will navigate to xOpera SaaS. We can go back to the documentation and let's find xOpera SaaS, which has a lot of components. We have GUI, SaaS API, the plugins, and so on. But we want to deploy our Hello World example from SaaS GUI. So the GUI is available on this URL, and from there I'm already logged in, but if you're not logged in, you will be redirected to the Keycloak page where you basically log in, and I can see the dashboard that it's opened, and I can just navigate into workspaces. The xOpera SaaS workspaces are basically just containers for your xOpera projects, and I will just create a new workspace, and I will call it test. So add a workspace. The workspace was just created, and currently we don't have any projects. So I'm just gonna add a project, and from there you can create a new project. Let's name it Hello, because this will be a Hello World example. And now I have two options. I can upload a TOSCA CSAR from my computer. Now I have prepared a different TOSCA CSAR files. So this is one way. And we also have an option to select a TOSCA CSAR that is stored in our template library service. And I will do that because it's simple, and I don't have to prepare my CSARs. So I will just find the Hello World example, which is right here. Click on it, and let's add a project. So this will start creating a new project. And in the meantime, we can take a look at what template library is. So we can go back to the documentation and navigate to the xOpera TPS or template library. So the template library documentation page is available here. It's a separate documentation page, and you can see that all tools are described. So we have, again, the GUI, the REST API, the CLI, and the Visual Studio Code or Eclipse plugins. But most important, again, is the GUI, which is available on this link. And this will take you to the template library GUI that has some publicly available templates that we prepared for everyone to use. So you can see that these are basically the templates that are similar to like xOpera examples. And if we click on some template like Hello World, the template is displayed. So we have a README, which is associated with this template. And of course, we have different template versions that are available because in the template library, we follow a similar structure like PyP or any other packaging page, which gives you the option to upload different versions that are immutable. And if I click on some other template, you see that this one has 4 different versions, and you can explore each one of those. Then the template library also has a component catalog where templates are basically grouped by their TOSCA type. So we have like node types, interface types, relationship types, requirements, and so on. And then we have a service catalog where the blueprints that are prepared to be deployed are stored. So this is our Hello World template. And then we have also template groups where similar templates are grouped together. For instance, we have AWS group with AWS templates. And of course, for instance, our company's templates are stored in XLAB group. So this is basically it. And a good thing about xOpera template library is that you can basically switch to the xOpera SaaS orchestrator right here. And this will take you to xOpera SaaS. We can go back to our workspace test, and we can see that the project Hello has been created from the CSAR that was stored in the template library. Okay, so we click on Manage Project, and the project management opens. The name of our service template was service.yaml. We didn't have any orchestration inputs. First, we can validate the service template, and the validation was successful, and we can deploy it right away. So the deployment started. We can click on this refresh button to see that the deployment was successful. And again, here you can see the inputs, the standard output, as which is similar as from the CLI, but it's a little bit longer because we used the xOpera's verbose mode to print out the output from Ansible playbooks too, and also standard error, which is not shown because we were successful and we deployed the template. And of course, you can undeploy. So undeployment in progress, and it was also successful. And of course, you can use this clean state, which will clean the current Opera deployment, and it will redeploy the template. So we started the deployment over and over. We can start deployment over and over again, and the deployment was successful again. Okay, so we can navigate back to our PyCharm, and I will show you our second example, which will show other xOpera commands. So you've probably seen that we have a lot of different xOpera commands, and a very good command is opera info. So I just have to navigate to compare templates folder. Let's clear that. Okay, and let's say opera info. Opera info will display the current status of the project. So we haven't deployed anything and we don't have any service template. But this compare templates example will show you the possibility of redeploying the TOSCA service templates. So perhaps let's imagine that you have the first service template, which is called service1.yaml, and it's almost similar than hello world example, but with some more node types. And you want to deploy that example with these orchestration inputs. So you can say opera deploy, and you can use first inputs and first service template. And a good thing about Opera Deploy is that you can specify a number of workers that will be used, and xOpera will try to deploy the independent jobs in parallel. So the deployment will be faster. Okay, we say Opera Deploy, but okay, the deployment was probably successful. Yeah, the status is deployed. And perhaps then we modified our service template and we got service 2 YAML. Perhaps like we deleted some nodes, we added some nodes, we changed some of them. And in this case, opera diff command comes in handy. So you can type opera diff, and I will use our second inputs file and our second service template to see the differences. So we see some nodes were deleted. Some of them, a lot of them were changed, and some of them were added. So it would be nice to have a command that could actually change our deployment according to these differences. And this is possible. You can do that using opera update command. So this will undeploy some nodes and deploy them back. And for instance, if your deployment fails, I have interrupted it manually, but if some error occurred, you can also explore this with opera info. It says error, but a good part is that opera deploy. So if you run update or deploy or undeploy again, it will start from where you left or from where the deployment was interrupted. Okay, so yeah, it's deployed. Okay, and this is basically how the opera diff and opera update work. Okay, so this was an example, the second example, and the next example will be a very special one, and it is in this folder. It's called scaling. So we can just navigate to this folder. So navigate back, scaling. Okay, so this example will show how the scaling can be established with xOpera orchestrator. So for instance, this template actually does nothing really, and it doesn't deploy anything, but it just shows how the scaling could be done. For instance, if you had two nodes, the first node would be an AWS Lambda function, which would be created, of course, on AWS platform, and this function would, for instance, do some sort of computing or processing. So again, you have create and delete operations, and of course, you also define some scaling operations, because you want to establish a behavior when in case that some levels like CPU usage or memory usage are reached, you want to scale down or scale up based on your usage. So in this case, you just link two playbooks, scale down and scale up playbook. And on the other hand, you also configure your monitoring service like Prometheus or so, and this monitoring service will monitor our AWS Lambda, and it will report this back to the orchestrator. And this example is special because it makes use of TOSCA policy types and TOSCA triggers. So we defined two policies for scale down and for scale up, and of course the two corresponding triggers with the scale down trigger and scale up trigger. And these triggers will be called by the orchestrator when the monitoring service detects that some levels are reached. So for these cases, we can just deploy the example first. So we say Opera deploy. So in this case, like you deployed AWS Lambda and configured monitoring. And after that, you can, for instance, if the monitoring service has detected some change, and for instance, that we need to scale up, you can say Opera notify, and you can specify which event we need to trigger. So I will put scale up trigger here because this is an event. And usually the monitoring will output some notification file with the levels or with the metrics. For instance, this would be an example of JSON file with CPU load and memory usage. So, and with -n switch, you can add this notification file for scale up. And you just call Opera notify, and this will notify the orchestrator about the change, and it will run this scale up playbook. And the same, it would apply for the scale down. Okay, this is a rather unintuitive or a rather hard in the CLI. So we also established a special behavior in xOpera SaaS that facilitates these scaling use cases. And we will take a look at it, but we will not put this scaling example directly into SaaS GUI, but we will use our two xOpera and template library Visual Studio Code plugins to establish this example and to run it. So, okay, we can head back into our documentation. And here, if you go to xOpera SaaS, you will find the information about our Eclipse Chip plugin. So this plugin is available publicly on OpenVSX or Visual Studio Marketplace. So it's here or here, but you don't need to download it manually because you can just go to your Visual Studio Code or Eclipse Chair or any other editor or IDE that uses Visual Studio and Visual Studio Code. And here you can go to Marketplace or the extensions and just type in xOpera. So this will give you xOpera SaaS and template library plugin. You can install those two plugins. Okay, they have been installed successfully. We can head back to our xOpera examples folder. And let's say that I want to download the scaling example. Now I've already put the scaling example to the template library. Okay, where it is? It's here. Okay, and I will download this example via the template library Visual Studio Code plugin. So you can basically just right click somewhere, and I will say template library interactive actions. Okay, I'm already logged in. If you're not logged in, you will have to log in first to the template library, because the login is the same as for xOpera SaaS. It goes through Keycloak, and I will not upload, but I will download the template. So I say download action, and here all the templates that I have access to are loaded, and I will pick scaling example. Okay, there is only one version of this example, which is this one, and I want to download it into scaling example.zip. Okay, the example is being downloaded. Okay, so it's here. And now I want to use this example in xOpera SaaS. So I will just right click on it and I will activate xOpera SaaS plugin. I will say create project from CSAR. Okay, I can pick an existing workspace, test, and the project will be called scaling. Okay, so the project is right now being created. So the creation of project can take some time, because behind the scene, the xOpera SaaS will create a new LXC container, which will be separated from other projects, so that your environment is really fresh. And okay, so here it is. Now we can directly deploy the project from the plugin, or I will not deploy it. I will do this in GUI. So do not deploy project, and I'm redirected to xOpera SaaS. Okay, we can go to workspaces. We can navigate into our workspace called test, and here it is. The scaling example was created. Okay, let's go to manage this project. Okay, we don't have any invocations yet, but we can deploy it similarly as from CLI. So the service template, we can first validate it, of course, and then you click on deploy project, and the project has been deployed. So, okay, now you have like established, for instance, your AWS Lambda and your monitoring service. And in this case, you can close this and go to this tab called triggers and events. So triggers and events, here you're able to create a new event mapping. So you click on create event mapping and you enter the event name. This event name can be found in your service template. So let's see, service.yaml. For instance, I want to create a mapping for scale down trigger event. Okay, I go back to SaaS, scale down trigger, and I map this event or this trigger to the scaling project. I add a new trigger, and xOpera SaaS creates a new unique callback URL, and this callback can then be called by the, for instance, by any service, by monitoring service, and when you call this, the trigger will be directly invoked. So you will notify the orchestrator about the changes and that it needs to scale down. And of course, we can create a mapping for scale up trigger as well. So we select scaling and add trigger. Okay, and for instance, we can say that our monitoring detected some high levels for the CPU and memory, and we need to invoke the scale up 2 times. So I will click on test callback. This will call this URL. And for instance, then after some time, we needed to scale down. Okay, so we can navigate back to our workspaces, and we can manage scaling project. And here it is. We can see that the notify operation was called 3 times. So the orchestrator was notified about the changes, and the scale up trigger was called 2 times, and the scale down trigger was called 1 time. So this is how you can configure your monitoring, or better, you can configure scaling with xOpera SaaS. Of course, always you can undeploy the project, which is a very useful operation if you don't want to forget about your resources. Okay, so all the operations were successful. Okay, and this was the creation of project using the two plugins for template library and for xOpera SaaS, and the scaling using the triggers and events. Okay, so till now we haven't really deployed any real use case project, but don't worry, I've also prepared one that will be pretty interesting, and it will be a real use case example. So this example can be found in xOpera examples. So just go to xOpera examples, and this will be a cloud example. Here we have different examples based on different cloud providers like AWS, Azure, Google Cloud Platform. But today we'll use Amazon Web Services. And we have a thumbnail generator with a virtual machine example. So this example will actually deploy the AWS thumbnail generator application. And this application will be able to resize our images and create thumbnails. So we will upload an image and we will get back thumbnails. And of course, we will also deploy the AWS EC2 virtual machine that will hold our web application. So let's go back into our PyCharm. And we don't need this anymore. We can head to cloud, AWS, thumbnail generator with VM. So this service template, here you can see it, is quite long because it has a lot of nodes. Okay, and all these nodes are separated into folders. They are in this modules directory. So you can see that different node types are separated into folders, and each node type has its own TOSCA YAML service template and its own playbooks for the creation and deletion, so that you can deploy and undeploy this thumbnail generator application. Okay, so let's head back into our service template. So all these templates are then imported into the main service template. And of course, we have a lot of inputs for all the AWS cloud resources. So for Lambda, for buckets, for our aliases, for roles, for EC2, and so on. And here we will go through the node templates that are actually invoked and deployed by the orchestrator. So basically what we do, we first just install the prerequisites for the AWS. So all the dependencies and all the packages, and then we create a new Lambda role. And in this is the most important part. Here we deploy the AWS Lambda function onto the AWS. So this Lambda can be found here. It's just a basic node type, but the function itself is written in Python. This is the image resize function that basically just took one image and it creates 3 thumbnails of 3 different sizes. So this handler is then invoked by an AWS Lambda. Okay, so this is our function. And then, of course, we need 2 AWS S3 buckets. This is the first bucket called bucket in, and this is the second bucket. So these buckets are needed for our images. So we want to reach the behavior where when we upload the incoming image into bucket in, and then the image is resized and the thumbnails will be in our outcoming bucket. But to detect that we uploaded something in our first bucket, we just need to also deploy our bucket notification. AWS bucket notification will be applied to our bucket in S3 bucket. And when an image will be put, it will basically call this AVS Lambda function. Okay, so to this row 128, basically this is a working application. So if we deployed everything except the rows below this one, we would have a thumbnail generator. But of course, we want to have some front end and some site that will display our images. And that's why we extended this example and added a few other nodes that include the deployment of AWS EC2 instance. So we needed to define the VPC subnet, the roles for EC2, the key pairs, the VM itself. We installed Docker on this virtual machine, and then we created a Docker image for our web app that is actually written in the Node.js. So this web app can be found in this folder. So web app is basically just a Node.js application, which also has a Docker file so that xOpera knows how to build a Docker container. Okay, and after the deployment finishes, basically we can also define the orchestration output, and we will output the public address of the EC2 web page, where we will see our web application, and we can try to resize those images. Okay, so we can head back to xOpera SaaS. Okay, we're on, here's the template library. We switch to xOpera SaaS, and I have already prepared a new workspace for this application, and I have already deployed it because the deployment can take up to 10 or more minutes. So basically, you might also be asking yourself how we can deploy the application without the credentials. xOpera SaaS also allows you to define your orchestration secrets, like your secret keys, your cloud provider keys, your SSH keys, but you need to go to this secrets tab, and here you're able to define your orchestration secrets. For instance, I have defined some my AVS credentials and AVS config that will be used for the image resize or the thumbnail generator example. So this is some secret that will be deleted. It's not important. And when you're adding a new secret, you basically just specify the name, like your SSH key, and you also specify a location where xOpera SaaS will put it when the new LXC container will be started. So for instance, like here. And of course, you can also set your permissions, like read only, and the contents. And then the secret will be added. And of course, you also need to assign the secret to your workspace. For instance, I can assign this secret that I have just created to the test workspace. So we go to manage secrets, and you just select the secret. I will choose this SSH key. I will assign the secret, and the secret has just been assigned. Okay, and similarly, I have assigned those two secrets for AWS credentials to this workspace, which means that when the projects in this workspace will be deployed, then those secrets will be made available to be used by the Ansible and the orchestrator itself. So let's see what is in this project. So I've already deployed this thumbnail generator example, which is also available in template library. I can show it to you. So here it is, AVS thumbnail generator with AWS EC2 VM. This is the latest version, and the behavior is also explained. So let's go back to see how the example was deployed. So workspaces, demo, and this one is right. So, okay, we can see that the deployment failed on the first time. This has never happened before, but it was I believe that there was some problem with the connection because the SSH needs some time to wake up on the EC2 virtual machine. But then, of course, xOpera offers you a behavior to deploy the application from where it was interrupted, and the deployment was successful on the second time. And also we can see the project outputs. So our EC2 web page address is available on this URL. So we can just copy it and navigate to this URL. Okay. It takes some time to load. And here it is. So this is our thumbnail generator application example that uses AWS Lambda and S3 buckets. So basically, when we will upload an example image, for instance, this one. And when we click on upload, the image will be uploaded into our incoming bucket. And after some time, the Lambda will be invoked and 3 thumbnails will be generated. So I can also show you this behavior in AWS console. So here is the Amazon S3. So our buckets are called demo bucket in and demo bucket out. So the incoming bucket has this example image, and the outcoming bucket includes 3 thumbnails. So for instance, you could also go back. You could go back to the demo bucket in, and here you could also upload an image. So you can click on add files, pictures, and for instance this one, you upload it, and the behavior will be the same as in the web application. So now we have two images in our incoming bucket, and if we go back to outcoming bucket, we will see 6 thumbnails because the 3 were just created for the second image. And if we want to display this in our web application, we will see 6 thumbnails. So this is how a real use case application can be deployed with xOpera and of course with xOpera SaaS component. So this is it for our demo today. I hope you enjoyed the demonstration. I hope that you will try our xOpera tools. And of course, if you have any questions, you can ask them after that. So I guess I will just stop sharing and I will give the word back to Chris.
Thanks, Andrzej and Mattia. There was a very, very exciting overview of the capabilities in TOSCA and what is possible when you create a full implementation of all the aspects of TOSCA. So very, very impressive demo and very exciting presentation. I think we want to open up, we have a couple minutes left, so we'll open it up to questions. I saw one question in the Q&A box from Philip. It asks, are all the TOSCA 1.3 features supported by the xOpera orchestrator? What are those features, or what are the features that are not supported? And have you added any proprietary features that should be added to TOSCA in your opinion?
Okay, so I can answer this one. Okay. The TOSCA 1.3, yes, we support most of the features. I think that the only thing that it's not supported are the TOSCA workflows, which are, again, a very special use case, but most of the TOSCA is supported and it can be parsed. This is about TOSCA 1.3. And yes, about the specific features, these are probably the TOSCA policies and the extension that we made with our TOSCA triggers and xOpera SaaS, but we didn't extend the TOSCA language itself because we didn't find any special use case that would be appropriate for us.
Yeah, actually, we just created that xOpera SaaS in a way that can proceed with the same specification. Just what I want to also to add to Philip, if there is something, please try xOpera, and if you find something that you would really need to be included, please go to the GitHub issues and please add a new issue for xOpera and describe what you would like to see in the next version.
Thanks for that and for that clarification and explanation. Second question from Juliana. It asks, there's actually two questions from Juliana. One is, how many of your 120 people at XLAB are working on xOpera? And the second question is, she noticed that most of your interface operations are described as YAML, which presumably represent Ansible playbooks. Do you support executable artifacts, and if so, how?
So for the first one, I guess that for xOpera, it's just a few guys, like 3, 4, 5. It depends on what we are doing. And regarding about the executable artifacts, I didn't get the question very well. So we have YAMLs for TOSCA, and we have YAMLs also for the Ansible part, which is the executor, or what you wanted to ask.
Yeah, probably she meant if we support any other tools
representation.
Yeah.
Oh, okay. I
So
guess that currently, no. Sorry,
okay.
Sorry, Andrea, go ahead.
So for now, we only support the Ansible playbooks to implement our TOSCA interface operations. But for the future, we can also extend that with like Bash scripts, Python, or so on, if we really find some use cases for this.
Thanks. And actually, that's a very relevant question because for those of you participating in the OASIS TOSCA technical committee, this is a topic of active discussion. I think this is a part of the TOSCA standard where some additional standardization would be helpful. So if anybody has ideas, opinions, experience, we invite people to contribute and to participate because this is an area that is seeing a lot of activity right now. Maybe one more question before we finish. Tal asks, can you compare xOpera to Cloudify in terms of philosophy and features?
First, I'll try, but actually, I'm sorry, Tal, I haven't used Cloudify ever, even though I know that some projects like XLAB started with Cloudify. So I'm sorry that I cannot then provide you a better answer for that.
So perhaps that's a discussion if you're interested, Tal and Mattia, you can connect offline and
sure.
explore if there may be some synergies or similarities that are worth highlighting. We're about at the top of the hour, out of time. But again, this was a very interesting, very exciting presentation. So thank you so much for your overview of xOpera and demonstrating the use of TOSCA and the powerful capabilities of TOSCA as the language. As I said, we have a very active technical committee in the OASIS community that's working on progressing the TOSCA standard. We've been working on a version 2.0, which aims to sort of much better explain the operational model behind TOSCA, introduce features to make it even more interoperable, more open, more extensible. And we are welcoming any help, any contributions, any experience that people may have. So if you're interested, please reach out to us and we'll happily make you part of the community. So thank you very much, and watch the TOSCA LinkedIn groups and the OASIS websites for future editions of this webinar series. we'll likely have a couple more over the next couple of months where we'll invite additional people to highlight their implementations. So thank you very much and have a great rest of the day. Thank you.
Thank you.
Thanks, everybody.
Thank you.